Hi, in this video we're going to be talking about the general power rule, which is really just a special case of the chain rule. So the general power rule will be used to differentiate a function of x raised to a power, type of a chain rule. So u will be some function of x. We will have u to the n. We bring n down. We will subtract 1 from the power. And now we will multiply by the derivative of that function u. Okay? So informally, we will call u prime the hook-on factor. It's really the crucial part of the chain rule. And really, we will always be using the chain rule, and it's going to be the end of this unit in every single lesson. Super important. So really we're talking about stuff that looks like, another way to notate this would be f of x all to a power of n. And the derivative of that would be, we take n down, we have the original function untouched inside, n minus 1, the exponent. And now we're going to multiply by the derivative of the inside function. It's times, okay? Not plus, not minus, times. Another way that some people like, it'll look like the derivative, some people don't like f of x in there, some box. So we're going to take the derivative the normal way. We bring down n minus 1. The package is still the same. We unwrap the package, and then we get to play with our toy where we multiply by the derivative of the box, the derivative of the inside. I don't really care which one you like better. But if you see parentheses with a power on the outside, you will very likely be using the general power rule. Okay, if you see two functions, one function inside another function, f inside a power, you will be using the chain rule, the general power rule. Let's get started. So immediately, I see exactly what I'm talking about. And I know that sounds like a crazy person, so allow me to rephrase. I see exactly an outside function surrounding an inside function. Christmas decorations. So, I need to take the derivative of this situation. My first step, my first duty to the teachers is going to be bringing the power down. I'll switch colors a little bit to orange. I bring the power down. I decrease the power by 1. I'm going to write that power here because so many people forget to write the power when they get started with this. I keep the inside exactly the same as what it was before. And now I multiply by the derivative of the inside. What's the derivative of x squared minus 3? Use the power rule, 2x minus 0. And if I wanted to, I could rewrite this in a nicer way. Again, from here on out, I'm probably not going to be writing that power on the outside if it's a 1. But do not forget to check the power. And if you wanted to, again, that's where I would stop on the test. But because of what we're going to do next, I'm going to simplify. Minus 12x. Okay? So just to be clear, that's what we're calling a hook-on. It got multiplied on. That's a hook-on. It's really important to pay attention to the hook-ons. You don't have to label them every time, but I'm just trying to draw your attention to it for what will come in 2 chapters from now. As always with our first example, or at least it feels like as always for lately, method 2, we'll just like FOIL it out, rewrite f of x equals x to the fourth minus 6x squared plus 9. And if I took the derivative here, 4x cubed, 2 times negative 6, negative 12x. Derivative of 9 is 0. And you see we get the same thing. Foiling or rewriting is a waste of time at this point, though. You get the same answer faster just using calculus techniques. So, it's right, but waste time. The hardest part of calculus is going to be deciding which method is fastest, which method will allow you to get your top score. It's almost always going to be the more calculus-y method because it's just less error prone than the algebra it requires to do this. Example 2. Here, the first step will be to rewrite anyway. I don't want to do outside, in, middle, and then inside. So first we're going to rewrite, and notice how I'm labeling this as g of x. I'm not labeling this as g prime. So we're going to write it as red. The green inside again, just to be clear. And I want to point out that so written, there is no other way to do this problem than the chain rule. This is why the chain rule is so important. It is required in some problems. Please be careful about applying it correctly. So, g prime, we will start by taking the power down. And here's what I'm saying. Let's just write the new power right now before we forget. 2x squared minus 4, I'm sorry, x, that's an x, it's clearly an x. That should be an x. Make sure you correct it on your paper. 3, 2, 1, let's go. All right, so now we multiply by the derivative of the inside. What's the derivative of 2x squared minus x? 2 times 2, 4x. Derivative of x is 1. Done. And again, there's no other way to get this answer. And I want to draw your attention again that this is a hook-on, and it's very important. The derivative of the inside is right here next to it. Notice how I did not take the derivative of that. Notice how I keep the power. If you can't imagine, here's what most people do on their test. They just forget to write the power there. And it's extraordinarily hard for your grader to understand, were you just being negligent? Or did you actually think that 3 halves minus 1 was 1? Careful. Because some people do 3 minus 1 is 2, 2 divided by 2 is 1. It's not true. Okay, another one. Ugh. Much uglier, much harder. So either way, my first step is going to be rewriting this. Hint. And the cube root is really the 1/3 power. And the reason this is such a hint is this also requires, the reason this is such a start example, also needs what we covered in the last section, the product rule. So, careful, careful. the derivative, we'll label it as f prime, equals first times the derivative of the second. And now here we need the chain rule. 1/3, parentheses. Let's write the new power. 1/3 minus 1 is negative 2/3. Keep the inside the same. Times the derivative of the inside. Derivative of 9 is 0. Derivative of negative 4x squared is negative 8x. Take a big, deep breath. I don't know why it's not letting me write. All right, here we go. That's the hook on for this. Careful. Does that make sense? We kept the first part the same. I probably should put all of the second part in parentheses. So let me do that. That's this guy's derivative. That required the chain rule because there's an inside function and it's all being raised to a power. But the outside function is the same, the first function is the same. All right, so here we go. Plus the second function, copied exactly the same from above. Times the derivative of the first function, which I'll use paint for. So, derivative of 3x squared, 2 times 3 is 6, x, done. Okay, so that last part's a lot easier than the first part, but this because it requires a product rule and a chain rule. It is no exaggeration to say that this is as hard as derivatives can really get. We don't do artificially hard examples. You will be required to do stuff like this. Just take deep breaths, calm down. It's all going to be fine. Next. It's going to be a slightly longer video. The general chain rule, this is how it looks for any composition of functions. We're talking about f is inside g. Or sorry, g is inside f. F with g inside of it. Functions inside each other. You must quickly learn to distinguish between the product rule, which looks like something completely different, and this. Let's say like, warning. This is not f times g of x. Go back and look at your notes for 3-2. These two are written completely differently. This one has 2x. This one has 2 parentheses with x inside of them. This derivative would be first times derivative of the second plus second times derivative of first. Much more different than this. This is still take the derivative of the outside function, keep the inside the same, multiply by the derivative of the inside function. This is still that. Okay? If it was f of box, it would be f prime of box times the derivative of the box. Okay? I'll write it like this. Okay? Be careful. We keep the box the same and then we take the derivative of it. You have to unwrap your package before you go inside. Some people call it the package rule for that reason. Please be very, very careful. This is not the product rule. So many students get lost there. So here's a classic AP test question. Sometimes they give this information with a table and students do worse. So they give you a lot of setup information and then they ask you to find the derivative of P of Q of X. This is not a product rule. This does not say P of X times Q of X. I know students see it that way because we use parentheses for both. Careful, this is Q of X inside P of X. So we're going to use the chain rule. So I'm going to write it really clearly. The derivative of this function equals, we take the derivative of the outside function. Now some students think this is very hard. The derivative of P is P prime. We keep the inside the same. And then we multiply by the derivative of the inside function. Notice how this is the exact same thing except we use P and Q instead of F and G. All I'm doing, it's going to be much more confusing when you start doing the product rule this way. Please be careful. So, at x equals 2, we have the derivative. This is usually the notation we use for evaluating a derivative at x equals 2. So again, that means evaluated. Evaluated at x equals 2. We have P prime, sorry. It causes a lot of slowdown. P prime of Q of 2 times Q prime of 2. I just replaced all the P's, all the X's with 2's. Notice there's no X to replace here. We're just going to calmly work from inside to outside. So over here, I have Q of 2. So that's P prime, Q of 2, not Q prime of 2, is 3 times Q prime of 2 is 2. P prime of 3, right here, 4 times 2. Now this is technically okay to leave as your final answer. This is not, this is not. These are not numerical answers. This is a numerical answer. Please be careful as you're working these problems out to not use the product rule. I saw so many people hurt their grade on their tests because they really don't see this as a composition. Okay, train yourself to see this as a composition. There's not enough x's for this to be two functions multiplied with each other. Please be careful. In general, most of the problems aren't that bad. I hope you saw that too. Good luck on the homework. Email me with any questions. Do some chain rule problems. Have fun. Bye-bye.